Hi, I'm the developer of the Inventory Framework plugin, and today I'm going to be covering over some debugging features in Unreal Engine. What I noticed through most of my technical supports with my plugin is that very few people actually know how to debug code in Unreal Engine and figure out where things are going wrong. So the top here, obviously, if you consider yourself a programmer, you must know at least the basics of when it comes to debugging codes. There's been a lot of cases where I try to help somebody and they don't even know what a breakpoint is and they just have print strings littered all about. Though this will not just be covering breakpoints and print strings, this is also going to be covering the blueprint debugger, widget reflector, ways you can debug with data assets, networking, visual logger, and some other handy dandy tricks to find the code that you are looking for. So first off, the breakpoint is probably going to be your most common thing. You can add breakpoints with the default keybind is F9. I use this so often that I have it key bound to one of the buttons on my mouse. So when we press play and we press T, it's going to break here and allow me to step forward and back, not backwards, but move around and follow the execution of the code. So if I put a breakpoint here, it's going to stop the game. The game is actually frozen. And I can go forward. I can go forward a single frame. I can jump to the next node. And these are kind of different. So here you can see I can step to the next node. I can step out. So then it would get out of this begin play call stack and basically go to the next thing that is queued. Step into allows you to step inside of whatever function you are above and so forth. And this here lets you just go back where it is to let you find it. For example, if you use advance a single frame, it's then going to go into this. Oh, it probably doesn't have anything hooked into construct, but often you will go inside of whatever function that you're currently hovering over with the advance to single frame. But most of the time, I just end up using this arrow. Breakpoints are critical for evaluating if and where data might be incorrect or the wrong functions might be getting called, or when they're getting called. And you can place them just during runtime. So if you're in the middle of a gameplay session, you don't need to close the game to place your breakpoints. While a breakpoint is being hit, you can hover over parameters to see their contents. So right now we're on this add to viewport. I can hover over this return value and see everything inside of this widget. I can also hover over the inventory component. I can also hover over this. You can hover over a lot of things. Though sometimes if I restart here, and let's say I put a breakpoint here, you can't obviously go here and hover over this. It's just going to say unknown because this node has not been triggered. Even if we go forward, this node has been triggered and it's get player controller. It's still not going to say it here because this is a pure function. It doesn't really matter if it's pure or not, but you get the point. Each node has to be triggered in some way for you to get this value. So here you can see this returned true, this returned the BP player character, this returned PC player controller, and so forth. And obviously we can't see the widget until it has actually, this parameter has actually been used in some way. So once we go forward by one, now we can see it. And we can also see the value of this variable here. And sometimes you'll see no debug data, for example. So like here, this isn't being used, so there's no debug data. Next is print string. Pretty much everybody is familiar with print strings. What a lot of people don't know is you can control whether they print to the screen, if they print to the log, which you can find output log. And here you can see there's a lot of messages being pumped out here. And in some cases, you might even want to put the out log here or somewhere else where you can easily see it. And you can also have a bunch of filters for it. And in C++, you can control where your messages, which filter your messages go into. I believe that's also the key here, but I'm not sure. Epic Games use print string very often, but it's extremely rare that they print them onto the screen. So your log might have messages for you if you're encountering weird issues or bugs. You can also place breakpoints on them. And there's also a kind of a hack. You can debug arrays by putting a breakpoint on a print string, then connecting your array to a length node and having the print string print the value of the length node. You can now hover over the array and see its contents. So for example, if I get container settings here, length. Oh, also, by the way, this is not just debugging like my plugin. This is just I'm using my plugin as an example. And here we can put this into here. And now, oops. Also, you can go into debug and here either disable all breakpoints or delete all breakpoints. So we'll remove that one. We'll press T. Now you can see it returns the length, but now we can hover over this and see everything inside of it. And this is one of my most common ways of debugging. But recently I found a better way of debugging this, which will be in the Blueprint debugger section. There is also a console command which makes your print strings much more findable. So if we put that there, you can see that it's printing out 26, but it's also saying which object is printing it out and where it can be found. So execute Uber graph, which I believe is the main event graph, but it will tell you which function and what graph is causing the print string. Next up is probably one of my new favorite debugging tools. I'm not sure when this was added, may have been 5.0, but this is extremely powerful, and I've only seen people talk about this on Twitter. Can be used to not just debug blueprints, but also C++ objects, so I'm not really sure why it's called the Blueprint Debugger. It lets you see any variables on any object live and constantly see any changes being made without using breakpoints. So if we take a look at how it looks, also you can find more debugging tools in this section here. And here we can select a bunch of objects. But in the next point, we're going to see insanely powerful when you have a lot of actors, but it's hard to find the exact actor that you want. So if we go into this window here, we can eject, and now we can click any actor we want. And we can see here in the outliner, this is BP player character. Let's first select what class that we want to filter this down into. So let's say the player character, but I have two of them in the level. And we don't know which one is which is why I'm ejecting here and checking the outliner in here. And I can see, okay, BP player character 0 is my character, the one I'm possessing. I can now open him up and see virtually everything inside of him. And let's just say I go into the inventory, and let's say I want to debug the items inside. Or actually, let's take a look at the tile map. So the tile map is basically the collision system. Let me close this. And tile 0 is this one over here, and then tile 1 is this tile over here. And you can see that the item ID ends with 273. This also ends with 273. It's basically saying what item is here. If I move this out of the way, you can see it becomes -1 and this spot is free. If I move the apple here, you can see it updates live. You can also see this happening here with the items. This is constantly being sorted. So if I move this note here, you can see this updates. Index 0 updates to be the note. If I move it back here, you can see it updates back to being apple. And it's being constantly updated by which ones are nearest to the top left, basically, going right, and then going down one section, going right, and so forth. And this is extremely powerful for seeing any data, basically, within any object in your level. What I forgot to write down is also you have this call stack here. Now, let's say I go into main HUD, let's say, and we put a breakpoint here. You can see it's very hard to go backwards. You can't really go backwards with breakpoints, but with the call stack, you can see basically how this breakpoint was reached. So we can see here, well, obviously it came from the event construct, but we don't know how this event construct got called. It got executed here when add to viewport got called. Some people might get confused and think, oh, construct happens when you create the widgets. But no, it actually gets constructed when you call add to viewport. And we can see add to viewport eventually got called by begin play. So this is how you can go backwards from breakpoints. The next tool is the Widget Reflector, which can also be found in Tools, Debug, Widget Reflector. And it lets you view the hierarchy and set up for all widgets, including the editor. So if I press pick, you can see all of this is kind of popping up. And it lets you see exactly how the editor is constructed. But not just the editor. It also lets you view UMG widgets. So you can see here, maybe I want to see where this quick slot is being added. I can hover over it, press escape to freeze it. And now we can go up the hierarchy to kind of find out where it's being added. If we keep going up and up and up, we can see, let's see, where does it go? It goes inventory, source, WBP inventory. You can also kind of see it in here, and it also will keep highlighting what you have selected as you go up in the hierarchy. So we can see this vertical box belongs to this constraint canvas, which is this entire canvas. So we must be close to the top. This still belongs to WBP inventory. We keep going up. It still belongs. And here we can see S object widget blueprint inventory. This is the root widget that we have added. And now we can do Control P and search up this. It's going to show a bunch of other things because it has the word inventory in it. But we can now see the same setup. We have our overlay here. We have our WS main screen, which we could see here. Though there is one bug with the widget reflector. If you move this window around, the debugging outliner will not move. So if we do this again, we select this and we now move this, the debugger doesn't move along with it, which is kind of annoying. But what you can also do is you can freeze this and you can modify the widgets So if we go into here visibility, we can just change it to collapsed or hidden. It should make it. Oh, I have the debug message, the debug image. It should be this, perhaps. We can go into visibility, collapsed. You can see now it has vanished, and we can change it back to hit testable or whatever it was previously. Yeah, self only. And we can even go crazy and just remove all of this if we wanted to. We can do a lot with this tool. So if I close this now, yeah, you can modify the values and see the changes happen instantly. This is extremely useful for finding out how and where widgets from other assets are being used. And this is also the primary tool to learn how the editor's UI is assembled and where it is assembled inside the codebase. So for example, if I wanted to know where this play button is being added, there should be more options here. Yeah. Address. I can click this. Source. Yeah, there it is. You can find out where exactly in the code base it is being used, though I believe you have to have debug symbols. Yep. You have to have debug symbols. I believe the last time I tried doing this without debug symbols, it wasn't working. You can also go down here into selected nodes, node as root, and this is going to make things a little bit more findable. So you can go here, selected node as root, and now the debug image that we selected is now at the very top instead of the entire window here being considered as the quote-unquote root. Next up, we have data assets. And what a lot of people don't realize is data assets don't block out the editor once you're in a live game session. You can see here, for example, you can't access any of these variables, but you can access these. So if I hover over this cool gun here, and we add a question mark to the end of it, it updates just live while we're in the game, though there are no events or any delegates that you can bind to update your blueprint codes. The only reason why this tooltip works is because the tooltip is created from scratch every time I hover over the item, and thus it gets the most up-to-date variables. So we can just rename this again and again, and it's going to keep updating. Next up is networking. And most people, when they start out with networking, forget that by default, clients will virtually have zero latency, leading to some code quote unquote working, but only under certain latency thresholds. You can enable network emulation to simulate packet loss and latency if you go into these three drop-downs, these three dots, advanced settings, and from here you can go into multiplayer options and you can enable network latency, enable network emulation, and you can set your own settings here for packet loss, minimum and maximum latency, and also outgoing and incoming. This next feature is experimental, but it seems to be completely stable. If you go into your editor preference, general, experimental, you can enable allowed late joining. You can also search it here, allow late joining. So if I set this to client, and I now add this add client, you can see that it emulates another person joining the lobby at a later state. This is critical for knowing if your code will work once another client joins the lobby, such as a equipment system. For example, you might have a multicast system for your equipment system, but multicast will only trigger once. So if another player joins, they're not going to receive that multicast. This is particularly important for new people understanding how to create quality multiplayer codes. Next up is a tool that I haven't seen used a lot, and I haven't had the chance to use it that much, and that's the visual logger. And basically, it is sort of similar to the print string, but it creates a timeline for you to review your to see what the value was at certain points. An example here in production.
Back in time, and actually you can even see the stuff being drawn here in 3D. So we can screw up back in time and figure out like what has the AI been doing. So we can see, okay,
the camera gets removed after a moment.
Rome was a score of 1, and set thrust was also a score of 1, so you will have picked a random one from those. In this case, that is setting the thrust, so it will set the movement. And then we can just keep going, and then we saw, okay, after a while, let's see.
Yeah, there it is.
So now that one's being triggered. And you can combine this with drawing all sorts of shapes as well. So then you can see actually.
So yeah, it lets you see whatever you want on a timeline-based visual. And in some cases, you can even see. You can also put locations.
These are just pretty much text files, so you will be able to.
I believe you showed it here.
Arrow keys, and it's going to proceed one frame at a time from the arrow keys. So you can see jump land, jump start, and if you look in the background, let's get closer. That was kind of silly. We're logging.
Yep, actor location here.
You notice when it gets to here, it says jump start. And then you can see the little.
And you can see the little blue dot is moving around. This can be extremely useful for if you're in production, and you can enable a debug mode for your players, and they can send you these log files, and you can see very accurately what is happening and when it's happening. And like the other example, it's very useful when you need to debug how a specific property is changing multiple times over a long period of time, such as this AI that he has here. Though these are the primary debugging tools and features, the rest of this is primarily other kind of stuff. So some tooltips give you more information when Control-Alt is pressed, though this most often gives information that is only relevant to absolute beginners. I recommend using the application Alt-Snap or Windows PowerToys to force your game window to be on top of the engine, especially for the Widget Reflector or not playing the game in a floating window. So for example, here when you select the Widget Reflector, and you have the window here, as soon as you press this, it's going to put the game window in the foreground, for example, which is just annoying when you're debugging, where with Alt-Snap and PowerToys, you can forcibly keep it on top. Writer and Visual Studio also have their own debugging tools, though they are mostly similar to the Breakpoints system. You might want to introduce yourself to their debugging tools. When you're using world partition, it is difficult to know which actor the .u assets are used for. So for example, if we go into your content, you can see there's this external actors folder, and these are just random strings. And most of the time you'll see this when you are committing, when you're doing source control, but you can't really tell what this is. What you can do is you can copy the name and put it here in the outliner, and it will show you exactly what actor this is supposed to represent. And this also helps you figure out what this external object is. You can see here, if we go further and further in, and we copy paste this, we can see it's actually the folder, visuals. It is easy to make assumptions about what is eating performance. You're a computer scientist, and scientists use facts and data to come to their conclusions, profile your game, or admit you do not know what is causing performance issues. For example, I was making a card game similar to Hearthstone where their attack and health were using a 3D widget. I thought the performance issue was ticking. I profiled the game, and it turned out it was actually the material the 3D widget was using, which would cause the widget to cast a shadow, which was getting updated every single frame. Technically, this is not really debugging, but this prevented me from debugging a bunch of other codes to try and figure out what the performance bottleneck was, to realize the performance was not my code. It was just this material that was causing issues. Dump ticks allows you to see all objects that are currently ticking, and I believe it outputs it into your output log, or yeah, it shows here. These are basically all the actors that are ticking right now. Object list class, and then you fill out what class you want to check. I believe if you also leave this empty, it'll just load all classes. This displays all assets that are loaded into memory, though you don't want to run this in the editor. You only want to run this in cooked builds, because the editor can sometimes give you false assumptions. For example, if I go here into geometry, meshes, template floor, this is not in the level. There's nothing referencing this template floor. It shouldn't be loaded in a finished build. But if I, for example, open it up and now close it, this command is now going to say this template floor is loaded, even though in a cooked build, it's not actually going to be loaded. So this can give you false positives if you are running it inside the editor. You can also debug meta sounds with this command. It's very useful. Code comments and text, most of the time you'll find this on tooltips, can be thought of as unique code identifiers. Code comments are very unique, meaning if you use Control-Shift-F, you can search all blueprints or the entire source code. Most code comments can be found by hovering over them. So, for example, you can hover over this. If, for example, you weren't able to just double click this and go here, let's say for some reason you couldn't do that, you can look at this text, returns whether this is running on a dedicated server. And you can just returns whether, what did it say? This is running on a dedicated server. And now you have the exact location where this code comment is. For example, you can, while inside your IDE, find exactly where the manage gameplay tags ... this text over here button is being created by just searching the text. This is how I learned most of my Slate knowledge, by finding examples in the engine that achieved something similar to what I wanted to make. So, for example, if I wanted to find this button here, where is it being made in the code? I could just search manage gameplay tags ... And now I can find two areas where it is possibly being created. And this has greatly narrowed down where I need to be looking in the source codes. This is also why a consistent naming scheme between you and your team is important, as it becomes very easy to find any code you need if you stick to consistent naming and comment your code. that has been it. There's obviously always way more resources for learning how to debug. I believe Unreal Engine also has documentation, blueprint debugging, a blueprint debugger, advanced debugging, and much, much more. There's even shorts about most of these tools, so you can quickly learn more stuff about it, though most of this seems to be still using Unreal Engine 4 visuals, such as this editor is Unreal Engine 4, though the majority of this is still relevant. But obviously some of this has not been updated. For example, the parameter variable hovering over showing all the information does not seem to be on here, for example. Thank you for watching. That was it. Hope you learned something, and I'll see you in the next one. Bye-bye.